Welcome to today's paper reading. Today's paper is titled, Text2SQL is Not Enough, Unifying AI and Databases with TAG. This paper was published on the AR14 preprint by Asim Biswal and colleagues from UC Berkeley and Stanford University. The abstract introduces AI systems designed to process natural language questions over databases, which promise significant value by combining the reasoning capabilities of language models with the computational power of data management systems. These systems aim to empower users to ask arbitrary natural language questions over their custom data sources. However, the abstract points out that existing methods like Text2SQL and retrieval-augmented generation (RAG) are limited in scope, focusing on a subset of queries that can be expressed in relational algebra or answered with point lookups, respectively. To address these limitations, the authors propose table-augmented generation (TAG), a unified and general-purpose paradigm that explores a wide range of interactions between language models and databases. This new approach opens up exciting research opportunities and highlights the need for further development, as evidenced by the author's benchmarks showing that standard methods correctly answer no more than 20% of queries. The code for the benchmark is available for further research. The TAG model is proposed as a unified approach to answering natural language queries over databases. It integrates the logical reasoning of database systems with the natural language reasoning of modern language models. This model addresses the limitations of existing methods like Text2SQL and retrieval-augmented generation (RAG), which are unable to handle queries requiring semantic reasoning or world knowledge. The TAG model operates through three key steps. First, it synthesizes the user's natural language request into an executable database query. Second, it executes this query to retrieve relevant data. And third, it generates the final natural language answer using the retrieved data and the original request. This approach significantly improves accuracy over traditional methods, demonstrating its potential to transform how users interact with their data. The TAG model processes natural language requests through three main steps: query synthesis, query execution, and answer generation. In the query synthesis step, the system translates the user's natural language request into a database query, often using SQL. This involves semantic parsing to understand the user's intent and generate an appropriate query. The query execution step involves running the generated query on the database system to retrieve relevant data. This step can leverage the database's query engine and may include language model-based operators for enhanced functionality. The final step, answer generation, uses the retrieved data to formulate a natural language response to the user's request. Figure 1 illustrates an example of the TAG implementation process for answering a natural language query about movies. The process involves three main stages: query synthesis, query execution, and answer generation. In the query synthesis stage, the system translates the user's natural language request into an executable SQL query. The query execution stage then filters and ranks the relevant data from the database. Finally, the answer generation stage uses the filtered data to generate a summary of the reviews for the highest-grossing romance movie considered a classic. The TAG model is versatile, capable of handling a wide range of natural language queries. It categorizes queries based on the level of data aggregation required and the knowledge needed to answer them. This includes both point queries, which involve retrieving specific data points, and aggregation queries, which require reasoning across multiple data points. The underlying data model can vary, from relational databases to more unstructured or semi-structured data formats. The database execution engine also offers multiple options, such as SQL-based query engines for relational data, vector embedding retrieval systems, and the use of semantic operators for enhanced query processing. In this section, we introduce the TAG benchmark and evaluate various baselines. The benchmark methodology involves selecting 5 diverse domains from the BIRD dataset, resulting in 80 modified queries that require either world knowledge or semantic reasoning. These queries are evaluated using human-labeled ground truth. The evaluation metrics include measuring accuracy as the percentage of exact matches and execution time in seconds. For aggregation queries, qualitative analysis is provided. The experimental setup uses Meta's Llama 3.1 model with 70B parameters, SQLite 3 for database operations, and an E5 base embedding model for the RAG baseline. Table 1 presents the accuracy and execution time for various methods on tag benchmark queries. The handwritten tag method significantly outperforms other baselines, achieving 55% exact match accuracy and an average execution time of 2.94 seconds. In contrast, the Text2SQL baseline struggles with accuracy, reaching no higher than 20%. This table highlights the efficiency and effectiveness of the handwritten tag approach in improving answer quality and execution speed. Table 2 presents the tag benchmark results, focusing on queries that require either knowledge or reasoning. The table highlights that the tag model consistently performs well, achieving over 50% exact match accuracy on both knowledge and reasoning query types. This performance underscores the tag model's effectiveness in handling a variety of query types that demand different cognitive capabilities. Notably, the handwritten tag baseline significantly outperforms other methods, demonstrating its superior capability in both knowledge-based and reasoning-based queries. Figure 2 illustrates the results of different baselines on an aggregation query. The RAG baseline provides an incomplete answer, while the Text2SQL plus LM baseline fails to utilize any data from the database. In contrast, the handwritten tag baseline offers a comprehensive summary, effectively combining data from the database with its own knowledge. In the field of Text2SQL using language models, prior work has utilized datasets such as WikiSQL, Spider, and BIRD for cross-domain Text2SQL tasks. These datasets focus on converting natural language queries into SQL, but they are limited to SQL generation without considering queries that require reasoning or knowledge beyond a static data source. Retrieval-augmented generation (RAG) has enabled language models to extend their knowledge by accessing large text collections. Models like Squad and HotPotQA focus on question answering over single and multiple document sources, respectively. The Dense Table Retrieval (DTR) model extends RAG to tabular data, and the tag model further enhances this by leveraging DBMS operations for exact computation. Prior work on natural language queries over semi-structured data, such as Stark and SQL, has explored the relational information between table entities and unstructured fields. These works primarily focus on search queries, while the current research aims to explore a broader range of queries by leveraging more language model capabilities for tasks beyond search and lookup. In this study, the authors propose table-augmented generation, TAG, as a unified model designed to answer natural language questions over databases. They developed benchmarks to study two types of queries, those requiring world knowledge and those needing semantic reasoning capabilities. The systematic evaluation showed that baseline methods are insufficient for these tasks. However, handwritten tag pipelines achieved up to 65% higher accuracy, indicating significant potential for future research in building tag systems. Thank you for watching.